The Webb Telescope's groundbreaking images have revolutionized our understanding. You can already hear it in the distance. Big Bang is over. James Webb Telescope finds a hint of another universe at the edge of the universe. Conventional physics may not explain the origins anymore. A thrilling development in the realm of space study has just opened doors to new horizons of investigation. Pictures taken recently have amazed scientists with an extraordinary find. A gigantic galaxy, tremendously larger than our home, the Milky Way, exists right next to a tiny galaxy, which we previously believed to be too petite to exist. This startling find has left space researchers perplexed as they grapple to understand how these unique space neighbors ended up being so close to each other. Conversations are bubbling throughout the space research community as they ponder the possible effects of this mind-boggling revelation and what more the universe may have in store. In the grand scheme of life and existence, it might seem that our lives are just a tiny drop in the ocean. But when we look up at the gleaming stars scattered across the night sky, we recognize something familiar and find ourselves wondering about their beginnings. Thanks to major advancements in science and technology, we now know that these heavenly wonders are made up of the same components that make up our bodies. Equipped with telescopes, we journey deep into the heart of time, unlocking the secrets that the cosmos holds. With every expedition, we venture further back into the past, questing the roots of our enormous universe. In this universe, you can hear the echo where the phrase, "Big Bang is over." James Webb Telescope finds hint of another universe at the edge of the universe. When the universe was young, it was bustling with newborn stars and galaxies. Through our understanding of cosmology, we can map out the evolution of these distant bodies, observing their astonishing transformations over billions of years. Our current guiding model of cosmology, the inflation model, has incorporated observations from mighty telescopes and the most recent advancements in physics. New findings from the Webb Telescope, however, are challenging this established view. The Webb Telescope, thanks to its superior infrared vision, has revealed secrets that call into question our previous understanding of the early universe. This groundbreaking discovery has added a new layer of mystery to the cosmos. Based on what we know now, a galaxy as large as the one astronomers have discovered should not be possible. This enormous galaxy, 10 times as massive as our own Milky Way, came into being only 500 million years after the Big Bang. This discovery has shaken the scientific community and prompted profound inquiries into our place in the cosmos. Are we on the cusp of a major advance in cosmology? Future research outcomes are currently only open to conjecture. The early universe poses a perplexing mystery to scientists from all over the world. It was once thought that the formation of the universe's largest galaxies would take billions of years. However, recent discoveries indicate that these enormous galaxies formed shortly after the Big Bang, only a few 100 million years ago. This rapid formation may indicate that the expansion of the universe occurred more quickly than previously thought, prompting us to consider the possibility of new forces and particles. The fact that these galaxies appear to convert all their gas into stars is astounding as well. Researchers are always eager to learn the answers to the question, what happened right after the Big Bang? In the midst of all this complexity, the Webb Telescope has supplied a revelation that's a game changer. Astronomers have made a historical discovery, a minute galaxy capable of producing its own stars. This galaxy exists 500 to 550 million years after the Big Bang, challenging our former beliefs and paving the way for new exploration routes. While initially perplexing, this discovery has expanded our understanding horizons, pushing us to dig deeper into the cosmos's most elusive secrets. It also propels us to question our current understanding and encourages us to keep learning, growing, and discovering the wonders of the universe. Astonishing new developments in the field of astronomy have left scientists scratching their heads. The universe has presented us with a spectacular display of cosmic fireworks, with stars being formed at an astonishing speed. But there's more to this story. The most fascinating aspect is that the smallest galaxy we have ever observed, a mere 16 parsecs wide, is responsible for this stellar spectacle. The Sun's distance to the edge of our home galaxy, the Milky Way, is approximately 40,000 light-years. As per data obtained from the Webb Telescope, this early galaxy really is that compact. This extraordinary rate of star formation in such a tiny galaxy has left astronomers puzzled. The mystery deepens with every new piece of information, and it threatens to overturn our understanding of the universe's early history. So, what exactly is this bizarre phenomenon? Could it be a galaxy, or is it something entirely different? Some scientists have proposed that it might be a star cluster, but its small size makes that hypothesis seem unlikely. The question that begs an answer is why our trusted cosmological model, which has been highly successful otherwise, doesn't account for these outliers. Do we lack a complete understanding of science? Or did the laws of physics behave differently in the early universe? According to one theory, these early galaxies are massive and brightly lit because an unknown mechanism accelerated star formation. Another theory suggests that the rapid growth of black holes could explain the existence of so many massive galaxies. But what led to such speedy growth of these black holes? The answers to these questions continue to elude astronomers, leaving them in a state of wonder about the early universe's mysteries. In an unexpected twist, Nobel laureate Roger Penrose theorizes that massive black holes from a preceding universe could have sped up the expansion of our universe. The recent discoveries by the Webb Telescope lend some credibility to Penrose's cyclic universe theory, which anticipates bright spots in the cosmic microwave background, CMB, as radiation from ancient black holes. Whether pre-existing black holes actually accelerated the universe's expansion after the Big Bang, or if there are other mechanisms beyond our current understanding at work, remains a topic of hot debate. Black holes are places in space where gravity is so strong that nothing can escape from them, not even light. Penrose thinks that huge black holes from an earlier universe may have helped our own universe grow faster. Imagine if we could rewind the universe's history, like rewinding a movie. Before our universe existed, Penrose suggests there was another universe. In that universe, there were big black holes. When that universe ended, it gave birth to our universe. And those black holes from the previous universe somehow helped ours expand quicker. Penrose's theory is known as the cyclic universe theory. It's called cyclic because it suggests the universe goes through birth, life, and death cycles. Now, you might be wondering, how can we know about these ancient black holes? Penrose believes that there are clues in something called the cosmic microwave background, or CMB. The CMB is like the universe's baby picture. It's the oldest light we can see, left over from a time just after the universe was born. Penrose thinks that bright spots in the CMB are signs of these ancient black holes. But here's where things get a bit tricky. We're not completely sure if these black holes from a past universe really did speed up our universe's growth. It's a big question that scientists are still trying to answer. Some scientists think there might be other things we don't know about yet that could explain why our universe is expanding so fast. The Webb Telescope, a powerful space telescope, has recently found some evidence that supports Penrose's theory. But we're still far from knowing the whole story. It's like a puzzle with many missing pieces. So, scientists continue to study and debate this interesting idea. Due to its complexity, no theory has successfully explained the unpredictable behavior of early galaxies following the Big Bang. It might be time to consider alternative theories about the early universe's formation. The current circumstances seem to challenge the standard model. If Penrose's conformal cyclic cosmology is correct, and black holes from a previous universe accelerated the expansion of our early universe, tracing the universe's origins could become impossible as his theory postulates an infinite chain of interlinked universes. Alternative theories to the Big Bang theory include the black hole universe theory, the multiverse theory, and the static universe theory. Subscribe to the channel for more such videos. Undoubtedly, future discoveries using the James Webb Telescope will shine more light on the early universe's mysteries. Be ready for a paradigm shift in your understanding of the universe. It's a thrilling time in the world of astronomy, and there's so much more to uncover. Prepare to be amazed as we continue to unravel the vast cosmic mysteries of the universe. The more we learn, the more questions we have, but isn't that what makes science so fascinating? For more answers, check out this captivating video at the end. It will amaze you as you discover the incredible things that await you. The James Webb Telescope holds immense potential, with numerous hidden clues yet to be revealed beyond what we can perceive with our naked eyes.